Okay, sir.
Morning, Saviour. How are you?
Fine, sir. Thank you, sir.
All right. Welcome to Coxylib. I just created a session now so that you can show me how you went about testing and writing test. Then from there, I will show you what I was expecting. Let's see how you have improved. Can you share your computer?
Okay. And it's sir, just a minute. It's loading.
All right. Are you winning?
Yes, sir. It's on now. Hello, sir. Can you hear me?
Yeah. Let me
Okay.
close here.
It's,
Yeah.
my system is up now. Let me ask to join. I'm asking to join now. It's loading.
All right.
No, it's still loading. So getting it. No, the Google Meet link is taking time, sir. It's still just
Is it loading on your side? What are you facing there?
yes, sir.
Uh,
Okay.
all right. I'm going to share my screen so that if yours is not working, you can check from my side.
Okay, sir.
Okay. Right. Let me share my screen. Then you can see my screen and then you can
Okay, sir.
tell me. Can you see my screen?
Yes, sir.
Yeah. So what I did is I went to the link that you sent me here. Just go to WhatsApp. Let me just check this message here. Okay. Right, here is what you sent me. What you sent me now. Good morning, say I've done all corrections. Please check again. This is what you sent me.
Yes, sir.
Right, let's check on the console. You see, it's not running now. Say that. Wallet data has already been declared on 29. So this is what you sent me now.
Yes, sir.
Explain it to me so that I understand. Although it's not running, explain it to me so that I really get to understand.
Okay. First of all, to test the functions, I had to create some arguments for them to properly test it. When I went and I searched for the functions in the Coxylib library, I discovered it needed some arguments for me to properly test these functions. So um, these constant variables I declared above, just some arguments needed to test the functions below, the const token mph, const policy, and every other one. So I started by declaring some constant variables that I'm going to use as arguments for testing um, each of those functions in Coxylib library. So that is what I started with. If you start from if you start coming from the up where I declared some arguments.
Your test, right? Am I right to say this is your test? This
Yes,
is
sir.
the test that you wrote to test wallet
Yes, sir.
essentials. This one here. So the next one, what are you testing here? You're testing SIP wallet, SIP30 wallet, then wallet helper. And then here you're testing value. And here you're testing this. And that
Prerequisite.
you're testing what here? Data. Testing this TX end. And then right, hex to text. This is what the function. And then
Yes, sir.
here you went up to what?
To 25 functions, sir.
How many are there? They must test all of them. All this.
They said I should test the one above. Yeah, these ones.
All of them. All this. We want to know these are without bugs. They are running without bugs. With the test library you have down. You have here. These arguments that you created to supply to the functions. It's what I don't understand because you were adding like dump this. I don't understand. This is completely wrong. If I want an argument to test the value, let me open here text pad and then we show you. I'm going to give you an example of value here. Well, I don't need to test the value. Why? Because value is class that comes with Helios. But I don't know, maybe there is somewhere where you must supply and test something for value. Wallet essentials value. This is something completely different. That value is wrong. That value you have created there, that argument value, completely wrong. This one is completely wrong. If I am to show you value, how it must have, it is not having a field like this. No, it won't have a field like that. Let me open the real blockchain and show you the value. But I will open one UTXO, then we go to the value part. Let's take one of these, this one, number one. Right, this UTXO has got output ID, hash output. It has address orange output. It has output. It has TX ID. It has UTXO IDX. Then it has value. So now, how does value look like? So I've opened value here so that you see. So the first thing you see in value, there is assets. Here are assets, two of them. You've got minting policy. Second one, we've got the token name. See, this part here is the token name. I can show you the token name by the index. You see, this is the token name. This tells us the name of the token here. And then the next number you see here, 3999N, is the quantity of the tokens. So if I want to know what token is that, I can say bytes to string online. Just we convert that bytes to a string. Do you see? Can you see my screen?
Yes.
Do you
Yes,
see?
sir.
Here is
I
the PID 68 share, whatever. This PID 68. So that is what I was telling you. The value, you see this value,
yes, sir.
it has got a collection of assets inside it. And then in this case, I've shown you one, which is this one. And it is 3999. If you go to your wallet, under your collections, you look for that 399. Let's go. There it is. Do you see? PIT 68 share FT 3999.
Yes, sir.
Yeah. So that is one part of value. Value has got collection of assets. It has got the second loveless. You see this second part. This is assets loveless. So loveless is the header in 1 million, so denominated under 1 million. So it's header. 1 million loveless is one header. So if you are to create a value object, say, for example, const seller value. If you are to construct this seller value object, so what you will need, you will need that value construct this one here. So I'll say new value. Right, but what am I going to put inside the value constructor? So the value constructor takes loveless. So this first one, loveless, is big int. Sorry, this big int is a formatting one. Then here you can put your loveless. Say 1150. 1 point. This is, let me put a simple one. So 1, 2, 3. I put an underscore. Come on. Yeah. Underscore. 2, 3. I put an underscore. So here I have put loveless, which is 1.5 header. And then you need to add your assets here. So for the assets here, seller assets. Now it's an object, seller assets. So let's create that. Assets. So you use new assets. Asset. Asset. Assets. Right. Because this is this. Now let's put some assets so that you see how the assets are like. Right. Assets needs three things. It needs the first, the minting policy, the policy. So let me say MPH. Second argument it needs is the token name in a hexadecimal way. So token name hex. And the next thing it needs is quantity. How many of these tokens? Right. So now we need to construct this here. Const MPH equals 2. So I am going to get a real MPH so that you see it, and a real token name hex. So we can use this one here that I have used for conversion. See this? This is the bytes part of this, but we need it as a hex. So we can extract it straight from here. Here. Right. If we go back to the assets, right, I'll open the assets the same way I did before. And then this is the policy. Where is the policy here? Right, yes. There is the policy. You can see in terms of how many bytes, it has 28 bytes. Then we don't need the bytes for now. We need the hex part, this one. So we're going to take this. Here I am showing you how to create value object correctly. So there is the
All right.
MPH we have. Next thing that we need is the token name in a hex format. This one We have it already. I've shown you. This is the token name in a hex format. You see there is a hex there. In a binary format, it has got 14 bytes, which are you see here. But we don't need the bytes. We need the hex part. So that is what we need. So in this case, we use this one. You can see. Now I've got the token name hex. Then the next thing is we need to state the quantity. How many, because the policy and the hex name is an asset, is a token. It's one token. The same way you see here, you've got this PID68 share FT. That's a token. How many are there? Like you saw here, we have a figure for these tokens. You see, there they are. 39999. That is the quantity. So that's the quantity we put here. Say QTY for quantity. So this one must be big int. So big int is a format recognized in the blockchain. Then here we put that 39999. That is the total number. So this is the correct way of creating seller value. So now seller value has got 1.5 header. It has got these 3999 a type of tokens. And this type of a token I've shown you here. It is this one. It is this. How many are there? This is the quantity we have. What is their policy? Their policy ID is this one. So now the combination of data and assets. You can have another group of assets here because this is a what? It's a collection. You can have more different assets here. In the same way, you open my wallet, you see all those different assets. So this is the correct way of creating a value object for testing. Now, if I want to test this using GMT+2, because now I've got a correctly constructed object, I want to test it using GMT+2. You can test. You see, this is why for me, I believe the best way to test an object is to split it, take it apart into its components, like in this case. This is the loveless. So I can say const loveless. Then I have it there. Then the loveless is here. See? And this is the seller. Now, testing becomes easy. You test these parts and let them pass. So let me show you. This is where now here we write our J test. Now, what property of minting policy do you want to test? Let me ask you one thing, Saviour. We want to
Yes, sir.
test this MPH. One, we see it is a string. That is the first property. MPH is a string. Okay. What
But
else?
it has numbers in it, sir.
It's a hexadecimal string. Do you see these quotation marks?
Yes, sir.
Yes. It is a collection of characters, but together the data type for it is a string. This one is a number. It's a number. This one is a straightforward number. This is a string. It is a collection of digits, but those digit characters there, they are considered a string. Those double quotes you see mean it is a string. So the first
Okay.
property, it is a string. Then the second property, its length. How long is it? So we can use count characters. You can check its length. I already have this here. Right, it is 56. Second property, it has got 56 characters in length. So those are the properties that are very clear about MPH. Okay. If you know another property to test that it is a hexadecimal, it is hexadecimal. I do not have a JavaScript function for testing hexadecimal. Test string is a hexadecimal number. Okay, so I need a function that can test number or not. Let's say JavaScript example, or if a number is hexadecimal or not using JavaScript. Right, there it is. How to check if string is hexadecimal using JavaScript? All right, they are giving us different ways of testing. They are using this. Pass a int h16, return a to string to lowercase. So right, this is one function is hex. Is hex, there it is. Right. Okay, these different responses, I like them, but how do I know they are right or wrong? I can test and use them. Let me check Stack Overflow. I think Stack Overflow, you might get a better function. So there it is. So let's use this one. Why? Because this one is a tick. Stack Overflow, they test these answers. When they put a tick, they test. Okay, so I trust this one. So let's take this. So I'm going to add it onto our Coxylib. Because I will tell you why. It's very important to know the string is in a hexadecimal format. It's correctly formatted in a hexadecimal. Okay, let's convert this into a function. Spot const. is hex, whatever you supply there. Then we return that. Okay. And we can
So,
use
sir,
it somewhere. All right. So let me show you here how to properties we can use to test here. We can test A. This is 56 long length. I'll show you B. Then we can text it's a hex format. Then I said C. We check it's a string because we have got that string. Yeah. So these are three different ways we can test MPH and be a little bit confident that it is going to work. So here now we are going to write three tests for each. So I'm going to say A, B, C. Right, let me start with the first one. This one is straightforward. Say j.log. You know how to do this. I've seen you doing it very well.
yes,
J-test. Then in this case, remember these three tests belong to the group MPH.
yes, sir.
That is the group. And then what am I testing?
The
Under the
value,
first
the
one here,
variable,
we're testing its length.
um,
Length is
yes,
what?
sir.
Is 56. Then now we put that MPH. Then we call on a matchmaker from the JTest library. Then here we say equal EQ. So here under MP, we need to call the length part like this, MPH dot length. And then we come here equal to 56. So this is a valid test. It's testing one property of MPH, which is the length. So we can go and test the next one. Right. So here, this will return true, this
MPH.
one. So here we are going to say we are testing MPH is X, is X. And then we have the MPH here. Right. So when given this MPH is hex, so here we are going to say bool.
Bull. Yes.
It must return true or false. But now we need to call this function is hex that I just added there to the Coxylib.
Okay.
When I say I call this function is hex mph, this will be true or false. It will be bool. It will be a boolean. So the last one, testing that this is a string. This one you know how to do it. I've seen you do it correctly.
Yes, sir.
So write mph. What are we testing here? H
MPH
is
is string.
in a string format
format.
as opposed to number, bool, whatever. Yeah, understand that. So in this case, we just leave it the way it is. And then here we
Bool.
call one method that will check, not bool, string.
Bool.
We use string. Do you see?
Oh yeah, sure.
String. It will say true or false if this is not in a string for format like this.
Yes.
But this string format, is it a hexadecimal number? This function will return true or false. So here is the three properties testing this. Now, when I'm using it here, then I'm using something that is correct. If any of these fails, then it means this value is going to be wrong. So you can go ahead test this one. This one is a what now? It's a token name in a hexadecimal format. You can test it as string. You can test also it is in a correct hexadecimal format. So now you copy paste similar test cases. Like in this case, I'll have the A test the is hex. So I copy this from there. Then I substitute MPH, place MPH with token name hex. There, the test is done. And right. And then the next part again, that I said, don't test the length because these the hexadecimal names. The names are of different length. They are not fixed. But we can test that it is a string. And I check here again. Remember, when you are running this can be null. See, this can be null. So you can test for null. Here, you can add another test. Remember, you write this thing once. So here I'm testing this MPH. MPH is not null. Then I check it. Then I put that null here. Okay, there it is. So this not null for MPH also applies to token name hex. So let me put it as C. Right, so let me put it in. Any question from your side? Saviour?
No question. You know, I was the only time I wanted to ask a question was when you were working on the is hex, but now I understand the function that what it does is to check if the MPH is actually in hexadecimal format or not, and that's just was the question I had. But you've explained it already. But the other part, I am following with it.
You are following it. So
Yes,
then
sir.
when we go to this quantity, instead of a string, we can check it's a number. So we'll replace this QTY in a number format. Then here, QTY, this is, you say, num.
Num, yes.
Oh, yeah. So this will check null. Null will be null. So want to check that it's null. It's not null. QTY is not null. You can again, you need to be, if you want to be a tester, remember testing is a full-time job. If you are doing well like this and you are doing it thorough, your job will be just writing test. That will be your job, to be writing test. Like you need to be thorough, like in this case, this quantity supplied must never be negative. Should it be negative? Here, when you supply this eta, do we have negative eta? No. Do we have zero eta? Yes. So here
Yeah.
we can put a property greater or equal to 0.
Zero.
We see that. So it needs to be greater or equal to 0. Actually, I can use this one here. This line for testing. So then here I'm going to put QTY. And then here I'm going to say positive. There is also another method that says positive. QTY is positive. And then
GE Q.
here. So here you can use GEQ, greater or equal.
So, yes, sir.
Then you put yourself. It's also fine. Here you can use also positive. Positive. I know on the matchmakers there is positive. You need to go through all those methods for testing and check which one, so that you don't run out of options to check. All right, that one we have tested it. Now, when we create an asset, give it this. If this passes, then we are passing here what? Something okay. And we are passing something here which is okay if all this passes. But if any of these fails, then you know here this fails. Quantity here, if it passes here, then you know here it's going to fail. Then if I want now a test for this one, here this must be an object. So it must be an object, because remember, you can make a mistake and do this in typing. When we are we do funny things. So that is why testing this integrated is a part is very important. Test. Right, this one here, which group are we going to say? This one we can put it under value. Yes, you can go under value. So it will be the only one. And then what am I testing here? That value.
Seller asset.
Yes, we are right. Yeah, you're right. You're right. That seller assets is an object. Then we supply it here. Then here we use object. I think object is in full,
Yes, sir. The full
like,
one.
like this. It will
Yes, sir.
pass if this is an object, but the way I have left it like this, it will fail. It will fail. It will even crash here, because this way is not correctly constructed. Right. What about Loveless here? Loveless is a number. The way you are testing Loveless as a number is the same you are testing what? Quantity. So it's a matter
Quantity.
of copying everything that is under quantity. You put it there. Don't take anything for granted. That is one thing I can tell you. Don't take anything for granted. The nice thing is you write it once and use it forever. In Chimba, when you don't need the test, you switch them off. So basically like this. Also, but here under Loveless, can we have negative Loveless? No.
No.
Must be positive. Can be 0, can be positive. So that one
But
is
sir, I have a for the get equal to, you could change the zero to one, the one we have in the big int. We use zero because it was just testing if it's greater than, if it's positive. But since we have a big int, do we change it to what we have there?
the big int. I'm not getting the question.
Like, since you're testing a Lovelace and we've given it a constant value of big int of 1.5 million, I'm thinking if the value in the get, greater than or equal to, would have the same value.
Yes.
And we just use equal to.
In this case, I said 0. So this here, this big int is Loveless. Yes, it's Loveless. It will check here if it is greater or equal to 0, although we have hard-coded it.
Yes, sir.
But remember, if it is an input from a control, an input box, it won't be always 1.5. It will
Okay.
keep on changing. In this case, I hard-coded it. We all know it's
Okay.
going to pass. But where this changes, when we are running, then it is going to give us a problem, because at one time it will be null. I'm telling you, this is a great way of trying to move towards quality code, not lying to you.
Okay.
Yes. Right here, we have integrated everything. We have got an integrated value. So this one is basically same with this one. You might say, why should I test it when I've tested before? No, here it is integration testing. You have put together Loveless and seller assets. It can pass everything up until here, but fail here if you forget a comma. Do you see that?
Oh, yeah.
So don't take anything for granted. If here you say value, maybe you spell it with a small letter. Changes can be something else. Or you say
Okay.
value, but you don't say new. It might not
Okay.
produce an object, might produce an array, might produce a tuple, might produce something else. So just consistently we come here and say now seller value. Seller value is an object. Then we replace it there. So now I have written my test now to test that thing, not what I see here. Let's go back to where we were. Here. Here. This is completely wrong. We have supplied a value as a field. They've created a new struct, or let's call it a struct, yeah, a new object. The field is loveless. You have given it this value. See, you have given another what? Object inside assets. And then this one, assets. This is wrong. Assets are not created this way. I don't know where you got this dump from. Don't go to ChatGPT. Oh my God. You'll never write code that works if you use those AI. One thing that we can do that will be awesome. I tell you, this one will be awesome. We create a specific function that tests a given object is value. I don't have such a function yet. So which means I can develop test functions on Jimba, where if you come across any object, could be a seller, value, we have it here, you just pass it to that function. That function is going to tell you this is value or this is not value. Okay. If we go to Haskell Bluetooth, sorry to digress a little bit. Check value. Let's go to compiling value docs. I don't know which docs are going to give us a better explanation. I want Haskell Bluetooth. Hard doc. Let's go value. Hard doc. Let me say Bluetooth. Yes, this one here. Can check if it opens. Good. Now I am going to search here for value. Normally comes under ledger. I've got a Bluetooth core. There it is, Bluetooth core. Value of. There is new type value. Yes, this is, they are creating value here. There it is. Value, new type value. Here they explain what value is. Let's read it. But before we read this definition here, let's read the constructors for value. Value, the constructor, get value. It's a map. It's a collection. There is a currency symbol. Then we've got a map again, collection, token name. And then we've got what? Integer. Now, you'll say, but when we were there, we never saw other currency symbol. It is blank. This is the correct definition of value in Haskell Bluetooth, and it has different functions. This is the different functions of value. Right. Let's go again. Let's go to source code here. Right, here is the source code here. Right at the top here. Make it a little bit bigger so that you can see. This is what they are explaining. Explanation. There is value versus a small value. Note the two are different. Let me not read. This is too long. You might feel asleep. But if we look at value here, we will always come back to a collection. Maybe here you say, what is a currency symbol? Click that, then it will show you what is a currency symbol. Currency symbol is a Bluetooth TX built-in byte string. This is a string. Currency symbol is a string. All right. This one is more complicated, but it's correct. What I showed you there is the off-chain code of constructing value. And then it will go and be changed into the on-chain code. Then you go to Helios book. Under Helios book, check value. Right, we want the capital value. This one here. Okay, check. Value type represents monetary value as a token bundle, internally represented as a map. See that? There is a minting policy hash, so that how we were testing it. And then a byte array, then int. This is the quantity. This one is the token names. It's a list of token names with their quantities and minting policies. Then there are functions under value on the on-chain part. But here we were talking about testing on the off-chain part. What I'm saying here is we should be able to create our own function that will test an object off-chain that this is value or it is not value. How can we go about doing that? This is my last part now. How can we go about checking that this is value or not? On the Haskell's, on the, what do you call it? Helios side, on the Helios side, we will need to check for the following two things. Number one, assets. If assets are empty, because this assets is a collection, if assets array length 0, value is still correct, but it has 0 assets. But if assets array is not there in that object, then it is not value. Second thing we can check is loveless. Is loveless a number and is there either 0 or more than 0? Yes, then it is a value object. If loveless is not there, then it is not value. So far, there are two properties to check value. That there is assets array, whether it's empty or it has something, it must have array of assets. This array of assets on the Haskell site, it is a map. It's a collection. Then the Lovelace second property, that there is a value called Lovelace, which must be a number. Do you see H int, Helios int?
Yes.
Once our function is given value, maybe what it can do, it can use a JSON.stringify, and then so that once it's stringified, then this will be a string. Then you check in that whole string that there is, what is present is assets. If assets field is not there, you can see there is a field assets. But when you open this assets field, it is an array. Is assets field included? Includes. Yes, fine. Then what type is the value of the key assets? Remember, it's a key value, key value. So we can check the value of the key assets. Is it array? We do have on JTest array. We'll say yes. Then we know the first property has passed. Then we go to the next one. Does it have a property loveless? Or does it have a field loveless or a word loveless? Yes. Is the loveless value part, because loveless is the key, loveless value part a number? Yes. Then now, whatever we are testing, we can, at least with confidence, pass it as a value object. So our function can be called isValue on the off-chain part. So here it will be extending the JLib. Sorry man, not the the chamber testing, but now it will be, this will be specific testing of the value. Then what we are going to pass on it is an object. Right. First thing, stringify. Object so that we are able to read its members. Then the next thing is check for assets key and assets value. The assets value can be there, but it can be a number. And then here we also and also that the assets value is an array. Okay. Then from there we move on to check the loveless part. We say check for key loveless, and that loveless is a number. If these two passes, then for me return true. If these two conditions pass, at least return true. Return true. If A and B pass, this will be A. You see, if you do this, I'll be very happy with you, because what you are doing now, You are extending the Jimba testing by adding functions which specifically check Helios classes, that they are what we are supposed to have. So whenever somebody is sending money from here to here, or you are minting tokens, or you are transferring tokens, remember all these things are moving in a container called value. Some of these containers are null, some of them are malformed. So it's very important to have this function. Is value, then we pass in seller value. It will return false. Why? It will check those two properties. Is it number one? Does it have the key assets? Does it have the key loveless? Does the value of the key assets, is it an array? If it's an array, even if it's an empty array, it's fine. And number two, does the loveless key, the loveless key value, the value part, is it a number? No, then it's not a value, fails. You see, when you are doing this now, you are creating a function on the Jimbo side that tests an object on Helios of chain. This is value, this is not value. There could be some other things left out, but at least checking those two key properties, let me call them properties, or checking those key members of the object is fine. Does this help you?
Yes, sir.
Right.
But- Okay, sir.
Yes, over to you. Talk now. I'm listening to you now. Here, you are creating a function, and then inside this function, this is already done on the Coxylib. This function is already there. This JLog is already there. Right. You are adding this part to test the payload. See. But what I want you to do, want you to test this function that it is correctly working. Okay. So how do you test it? This needs an address. So you need to supply with it a batch 32 address. So create a variable const batch 32 test address. Then you go and get the actual batch 32 address from a wallet. Like this one here. Yeah. And then you call that function. Here you are supposed to be calling the function. You are not supposed to be copying the function on the Coxylib, bringing it here and creating it again. That was the other part that I was asking you to do, but it has lots of bugs. It's not running, it has lots of bugs. I had to comment it out. If you check clearly, go clearly to where I've changed it now, you'll see what I'm telling you. So all this, definitely, let me tell you one thing. If we take this to Cardano and say, these are the tests we are writing, they are wrong, completely wrong. I'm going to give you this and also paste this on the, let me also paste this. Yeah, there are two. This one. I'm also going to try it Examples of tests. I don't know where to put this. Maybe I will sit down and write a document with testing, the same way I'm showing you here. If we want to see this really works or it doesn't work, then we can run it live on my, I've closed that again. Remember, I've closed that again. But this is I can paste it here. Saviour, where's this one? Coxylib. I don't know if it helps or it doesn't help. When I gave you this, did you read it? I think you didn't read it. Did you read this, what I posted on WhatsApp?
Yes, I went through it, and also I went through what you sent to me on the group, and that was why I asked the question whether the error I was having was with including the J dot test, and
Because I'm
you said that
expecting
was
you
the
when
issue I
you
was
give
having.
me the answers, the test. If you give me your test, like you say, here are my tests, I must be able to run them and get this. Must be able to run them and get this. Something like this. We must be able to get that. So if I can't run them and I can't get that, then it means you have to improve on that. Who else is doing test?
I think Israel.
He has not given me anything so that I can say, when did you last speak to him?
Um, no, not been. He's been. The last time we spoke was when he had exams, so he has been having. So aside from that time, I don't know whether
Let us
not even
test
spoken.
now. You saw what we wrote here. This, what we wrote here now. Here. Let's try to run it under expect, because let's try and see. Let's run it under expect. So I changed this index and I put expect. Right, let's correct. It says expect.php not found. Oh yeah, spelling error. This is expect. How did I spell it wrong? Copy it correctly. Hey, look at what you see here. Look at what you see. Right, you can see, first thing it says is hex is not there. So I'm going to add easy hex here for you. I'll add it here, but you'll have to put it on the Coxylib. You need to move it to the Coxylib. J.test bool is not a function. Right. It's a small p, am I right? So I wrote a capital P. If you look at these functions, none of them is a capital letter. So this is wrong. It's supposed to be small p. Here, small p. Right, let's test again. Right, here we are. Let's go on. Right, then we get here. Cannot convert this to big int. Where is that? Object. Right, there is a mistake there, or a J value seller is an object. Seller assets is an object. Right, it is saying cannot convert this to big int. Let's take out that test. It needs, let's take out these two tests. This one and this one. Maybe this one is going to also produce the same. Let me leave this one. Right. Here, QTY must be big int. There's one thing I left out here. Big int. Any number must be big int, but I did make it big int there. Then now, let's leave it like that. Let's test again. I simply commented out. Oh, I didn't solve that problem. So here, set new value for the seller assets. Ph token name hex. Come again. Come again.
No, nothing, sir.
I will comment out this. I'll need time to look at what is the issue there. So I'm commenting it out. Oh yes, I've commented out this one, so we can also comment out this one because it depends on the line that I commented out. Okay, Saviour, what I want you to see, look, what is passing, what is failing in. Look. That is what I want. That's how we're supposed to. Then you can see those that are failing. Then you can attend. This is, let me take a screenshot. Produces this. The whole goal of this is to make all tests pass. but they must exist. Okay. There we go. But I have a feeling people are not reading these examples. They are not reading this. They are reading, they are not writing test. If they were writing test, I should be having this, because this is what I need to submit to the catalyst. This. Right, I am going to put this in your, I've already edited it here for you. You can't fail now, Saviour. Take your time, write it this way. Are you with me?
Yes, sir.
Write it this way. And then call Israel and say, this is what Say gave me. This is how it works, like this, and see if Israel understands it. I'm recording this. I'm going also to publish this video. And then from there, you carry on. You must test this way I am showing you. I want all these functions tested until here. If you can test all these ones, you are calling these functions. Some of them, they are for minting, some of it is for updating. You call it. Give it the right arguments. See, it's running, it's not running. What are the problems? Let me tell you, let me show you one thing. I'm going to do a Coxylib real world application on industry, which is on property industry test. We are going to test that. I'm failing to express myself. Sorry for that. But I mean, I'm going to have a session where we test Cardano property solutions, which is implementing the test lead. This you are going to see some of these, they generate a lot of errors. It is because the testing is not thorough. The testing is thorough and we iron out all these issues here. Then we run, then we fix, run, fix, until everything is green. Then the app becomes better. I can give you this, you test it also on your side. Here is the link. You can test it also on your side. I put it there. You can also test it on your side. All right. I think let's stop this session. It has gone too long. But with what I have given you now, you go and improve, work on expected. You know, you've got index file. Work on expected. Please, maybe we can do 1, 2, 3, post them to me to check. Am I on the right track here? What you produced is different. This will never test anything. It will never run. Even on your side, it's not going to run. It's not going to give you anything. How is it going to run? It's not test. It is not test. This one, compare it with this one. All right. Let's stop recording here and stop this session. Any question from your side?
Um, okay. Um, okay, the only question I have is looking at what I did, and maybe I would go back and check again. I was thinking that um, I was following what you gave, but yet I'm yet to really place my hands on why the thing it didn't run actually, because even previous test codes I've been writing, I this is the format I've been using. The only difference here is that I had to generate arguments myself, but I made sure that the functions were properly called. I don't know why it's not running, but maybe I will do follow the new code you sent, sir, and run some tests again.
If you go and check what you wrote, I don't know whether you used AI to generate that or what. I don't know how you produced that.
Just the argument I used AI, but the rest I wrote them myself.
The AI knows nothing about Helios, knows nothing about Coxylib. That is why we have to create even those is value function for Jimba to be able to test properly. My suggestion is, remember, we try. At some point, you are going to break through. Once you break through, then you keep that. I'll tell you, this is okay. This is okay. This is fine. Because when you run yourself, we'll be seeing the test pass, fail, pass, fail, pass, fail. And we'll be seeing the code coverage on your unity test. We've covered all areas. Then we will have more confidence in the software. If it is not doing that, then we are not testing. We are not testing. All right, I will upload this video. Then you can go through the video again and again. Listen, see how I am approaching it again and again. If you have got some doubts about the testing that I'm doing, compare it to other bigger libraries like Mocha, whatever. And then also, if you don't understand testing, read into what is testing? What is the purpose of testing? How can I test? This one is the simple beginner's testing code. That is what I say. If you go back and produce what you have produced, because you produced it the first time, and you came and you produced it here, but I'm showing you, go and see yourself. It is not running. Do not rewrite the Coxylib functions on the index. They are already there on the Coxylib, defined. They are already called there in the list. That is one thing I'm saying. What we need to know is when you call that function, give it the argument it needs. Will it produce expected results? One thing where you are right, please don't get me wrong, where you are right is when you say those functions need arguments. Yes, you need to give it arguments. But don't go to AI to get it generate argument data for your functions when it doesn't know those functions. It will give you what it gave you, completely wrong things. That value you provided is completely wrong. And this, I doubt if it's only value. Let me see these other arguments you were trying to. No, this is not it. No, this is completely not it. See, these wallet arguments for even wallet essentials. No, it's not it. Completely. No, 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 no. Oh my God. You are saying C SIP30 wallet field true, false, boolean. No. No, 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 no. This is not it, Saviour. Uh, Follow what the example I gave you and this example that I've given you. Then get somebody, maybe Israel or somebody else, who's a developer, sit down on it, check it, understand it, and then do 1, 2, 3 demo, send it to me.
Okay, sir. So that means if I'm to get the argument, I can follow the method you used in the video where you ran the Cardano property solutions and you inspected, and from there I get the arguments I needed, right?
Follow the expected. You see that file that I have here, which says expected.
Yes, sir.
Under expected, when you see there, what do you see? What do you see? You see j.test. It is testing something, either the length of MPH, or it is testing it is hex, or it is testing it is a string, or it's testing it is null. You get me?
Yes, sir.
Yes. So that is what I gave you as an example. Why? Because you produced value. You created value as an argument. You constructed it wrongly. But here I've shown you how to construct value and how to test its members. When you split it into pieces and test each piece, it's easier for a complex object like value. Value is a complex object. It's a highly complex object from my side, where I can explain it. Right. How to call the functions. I gave you previously how to test prerequisites. I give you example, TX
Yes, I got the
prerequisite.
yes,
That
I got the
was,
example.
yeah.
Yes, sir.
Right. Maybe let's look at another function here, TXN. Your TXN, you gave it a wrong argument. Why? Because you are using, where I saw TXN where you were testing. Because you're using AI. My man, if you are using AI, I don't think you are going to make it. Until you understand this and you understand AI, then you can use both. Otherwise, AI has produced something completely wrong. It's not even running. Run it yourself and see. And then after running and say, what benefit am I going to get out of here? The Tx is a function. It takes a transaction as an argument. If you are saying, all right, let me create an argument for testing the Txn, then you must create a transaction object correctly according to the Helios of chain. Must instantiate Tx object of a class Tx and begin to give it some member values at output, add redeemer or whatever, or mint, add signatures. All right, let me stop recording here. Go and try again.